Hi, I'm Philipp. We'll talk about today the perils of the cloud, the dangers of the cloud. Shortly about me, I'm from Vienna, where I organize some local meetups. And I've also written a book about a PHP-based CMS called Silverstripe from New Zealand, which hardly anyone knows in Europe, but if you want to talk about it, come to me. Today we're doing something different. Well, we're talking about cloud computing. That's where I work at a small company in Vienna, which does automatic exchange of messages like orders and invoices of shops. So if we screw up, terrible things will happen, like beer will run out. So that's why for us stability is very important, and that's where the danger of the cloud comes in, because for us it's always important that the cloud is up and running. So to start off, who's using Amazon here? Okay, a few. Okay, someone from Amazon, obviously. Who's using other cloud services like Azure, Google? Okay, who's planning to go to the cloud? Okay, anyone totally opposed to the cloud? No? Okay, good. So let's see. Why is the security so important? So there are a few big cases. For example, there was Codespaces, which was like, I think, code hosting. And they were hosted on Amazon, and someone got to their key, their Amazon API key, and then tried to blackmail them on some, I don't know, some big amount of bitcoins, and they didn't want to pay and tried to lock him out. And then he basically shut down all their services. And he terminated all instances, he deleted all backups, and they were gone, basically. They didn't have any other backups. The service just vanished, and that was the last message they put up on their website, like, everything has been deleted, we're out of business, goodbye, basically. So, yeah, everything's gone. Not so good. Then there was DrawQuest. I think that was a little game, but it had many loyal players, and it has been going on for quite some years. And they, again, someone compromised their Amazon key, and in the end, they had hundreds of expensive servers running, mining bitcoins, and since it was only a private project, they had to shut it down because they didn't have the resources either to pay the bill or to clean up the services, and they were again just gone. Because it totally makes sense to rack up a bill of like 5,000 euros on Amazon bills to generate like 1,000 euros of Bitcoin. But yeah, that's just bad policy. And then there was another very nice incident of Bonsai. I think they provide Elasticsearch hosting, so they provide the search feature for other sites. And someone, probably an ex-employee, but they never really were sure, exposed their key and terminated all their instances during the night. So they woke up in the morning and the whole infrastructure was stopped. And luckily they were pretty much automated and could rebuild all the servers between 5 and 24, within 5 or 24 hours. But still, it's not so nice if someone is able to shut down your whole infrastructure. So, okay, I know how you're feeling. But there are steps to avoid it. I'll try to comfort you. And now we'll talk about how to do that. So first off, how do you secure your Amazon infrastructure? In 1,100 easy steps, we'll take a look. Yeah, I know, it's quite a lot of steps, and you're waiting for lunch already, but let's go over them quickly. So, 0, lock away your root account. If you sign up for Amazon, the first account you get is your root account. That's not limited in any way. Just put those credentials in your safe and really never use them again. If someone gets them, you're totally screwed. There's just no way about it. So what you should do instead is use Amazon's identity and access management called IAM, where you can create additional users and they can have different kinds of restrictions, which we'll also see. So remember, IAM is your friend, always use IAM, and just so you wait, give me a second. what IAM is, you'll remember. Yeah, and that's really the key message, because on Amazon, IAM is really what you are, because that's what you log in, what you're allowed to do, so IAM is what I am. Create an IAM user for every service or action. So if you're using any kind of third-party service, don't give them some kind of full access, create a dedicated IAM user for each of these services, and really lock it down as much as possible. So for example, we are using a build server. You can either host it yourself or use an external service. Create a specific user for that build server. So if your build server gets compromised and somebody gets that key, all he can do is probably push code to your live system, but he cannot terminate your instances or do anything else. So really separate the credentials, only allow what the service really needs to be allowed to do, and create one user for each service. Yeah. User groups to manage permissions for users. So you can either set permissions on a per user basis, or you can define groups. In general, always define the groups, because you want to be able to reuse permissions. Groups, unfortunately, cannot be nested at the moment, I think. But a user can belong to multiple groups, so that's the kind of nesting mechanism Amazon supports there. And as you've noticed, we're progressing quite nicely because the numbers are in binary. So next, lock down users and groups as much as possible. Amazon has, at first it's kind of weird syntax with JSON, how you can configure it. That's what a basic rule would look like. For example, you say, I allow something, for example, these two rules. So S3 is the file storage Amazon provides. And with this rule, you would allow to list all the buckets. A bucket is like a container on S3 where you can store your files. And you can list all your buckets. And then there is a second rule. You're allowed to store objects, to retrieve objects, and to delete objects from the bucket name, column example.backup, and everything below that. So you can see the list of all available buckets, and you can only get, delete, and put objects into that single bucket down there. So that's how you would define all your access credentials. So you can do that for creating and termination of instances, for S3, for access to domains, for Amazon's queues, and all the other services. You can create dedicated rules. Who is allowed to do what specifically on that service. And you would attach that JSON statement to a group, and then put each user into a group for the stuff he is allowed to do. Yeah. Generally good advice, use good passwords. The host tables thing from XKCD, you all know that. How to get good passwords, or just use a password manager like 1Password or Keep Password. Generate the password, use it for a single service, store it in your vault, and just retrieve it from there. Nothing else to do, and you're on the safe side generally. Okay. Next up, multi-factor authentication. That's something Amazon supports. So multi-factor authentication is normally it's two-factor authentication with two things. For example, you have your passwords, that's the knowledge, and then you need to own something like your phone, where there's a code, so only if you have both the knowledge and the ownership of the device, you can access your resources. You can enable that both for your root account and any IAM account you want to log in, and you should definitely do that. So even if somebody steals your password, if he doesn't own your phone as well, he cannot access your account. So if you have a login, normally your Amazon login would look like that. You have the account name, the username, the password, and if you have enabled your MFA code on your mobile, you would get the additional field at the bottom, and only if you have all those 4 pieces of information, you're able to log in. Otherwise, you're stuck. What happens if you break your phone? Unless it's the root account, there's no problem, because as long as you have some root account or IAM user with a lot of privileges, you can easily reset your phone. However, resetting the root account's multi-factor authentication device is more difficult. Then you will need to answer the questions. So you can provide security questions, and only if you are able to answer those security questions, you can reset your device. We've tested that in practice. Unfortunately, so it wasn't me. So a colleague had the root account and he broke his phone, not me. And he put the security questions. He just generated random values and put them in the form. And we didn't know those random values anymore. So you should not do that, because then we really had to test out Amazon security. And we have paid support, and we have a named contact, and we tried to regain access to our root account, because we said, okay, look, here we have 3 accounts here, all of the email addresses, they haven't been changed in like 2 years. All of us will be able to verify that we want to get back our root account, you have our phone numbers, call us, but they cannot do that. So if you've lost the multi-factor device of your root account and you don't know the security questions, you need to get the signed notary form to reset your account, which is both quite a hassle and pretty expensive. But there's really no way around it. We tried for like a month, because normally you lock away your root account, but at some point you probably want to regain access to it, but we really were not able to get access to that. So yeah, on the one hand it's really nice of Amazon that they enforce strict security, on the other hand it's quite a hassle. So remember those questions, we're still using random values for our security questions so that no one can easily guess them, but we are now storing those values along our keys. This is probably the most important thing. Never commit your credentials. That's what happened to most of the services at the beginning which were hacked. They put their credentials in their Git source code, Git source controller, and at some point, or I think most of the issues arise when at some point you start a private project, you put your Git keys in there, and at some later point you decide to open source your project. And even if you've deleted the files, they're in the history, and at some point somebody will find them. I think Amazon is by now scanning GitHub for keys, so there's a simple regular expression for Amazon keys, and they're continuously scanning GitHub for keys if somebody publishes his keys by accident. But sometimes they're not quick enough, and the bad guys get the key first and then wreak havoc. And at other times, Amazon is able to notify the customer first and say, hey, you committed your keys, throw away those keys, otherwise you will get compromised. And it definitely will happen. The bad guys are also constantly scanning GitHub because it's really a cheap way to get Bitcoin mining instances. And one thing we actually absolutely rely on is IP restrictions. So if you have an IAM account, as said, for root accounts there's absolutely no restriction, but for IAM accounts there are these IP restrictions. We define a rule. So even my user to log into the Amazon Web Services web interface is limited to our office IP address, and either I'm at the office or I need to connect to the office via VPN. But otherwise, even if you have my credentials, so both my password and my two-factor authentication code, I cannot access the web interface or any other resource from the IP here, which kind of makes sense because normally nobody should be able to access your account from like China or wherever, where you hardly are. So we are always restricting our IPs, like you see at the source IP, that's the thing you're looking for. And if it's not the request from that IP, you will just get basically a blank page because you're not allowed to do anything. So it would, that's how the page would look like if you log in. But at the top there, you would normally see all your instance details and stuff like that. And here you have just, you're not authorized to describe running instances and everything else. So That's a little confusing at the beginning, because if you are connecting from the wrong IP, you can actually log in and you can issue commands, but you will also always get the denied back, basically. But only if you're coming from the correct IP, you will get full access. One thing we found very helpful is enabling billing alerts, because the bad guys are normally not stupid. So if they compromise your account, they wait for the beginning of the month. So after you got the last billing statement and you saw, okay, I paid my $10 and everything is good. And then they start mining on the first, and then they mine, or Bitcoin mining or whatever, they use your account in an illegal way for a full month. And then instead of a $10 bill, you get a $5,000 bill. But you will only see it at the end of the month, unless you've added billing alerts, where you will get an email and you can simply set at the specific points when you want to get an email. So for example, we get here, we have an example, we have a $2,000 alert, and we know we are getting that pretty much at the end of the month, because our bill is normally like slightly over $2,000. And if that email comes much earlier, we know, okay, either someone has compromised our account, or, which is more probable, that we have screwed up and have started too many instances or have done something else wrong. So it's not only a good way to protect against the bad guys, but also if you screw up yourself and start something you didn't want to start, so you will notice early on if stuff is not working out as expected. The thing is, you cannot say, okay, send me an email every $1,000 or every $100. You need to manually set each step. So we have created like a $1,000 alert, a $2,000 alert, and a $3,000 alert. And if you ever see that $3,000 alert, we really know, okay, something is wrong. Shut down everything, basically. And the last but one point is enable CloudTrail. So this is another very nice feature of Amazon, which I don't think you have with most other cloud providers, where they actually log who has been doing what at what point in time. So here, that's one entry, for example. We see that the user account Alice, with some example key ID, like on the 9th of May 2015, stopped an instance in the EU West 1 region, and it had that IP. So if something has been going wrong, this is really helpful to see what has actually been going wrong. Because if you wake up in the morning like Bonsai.io did, and all your instances have been terminated, the first thing you want to know is which account has been compromised, which account do I have to lock, or where do I have to rotate the keys. And only if you have enabled the CloudTrail, you can actually see in the logs, okay, this one account has been stopping all the instances that has been compromised, so disable that account. So that's really helpful after something has happened to see what has been happening and how can I clean up for that. And then there is the security status, where you have on your account, you can see all the things you did, good or bad. It's just a little overview. So you see you have multi-factor authentication in the root account, you have different IAM users, you have groups, you have a password policy, and you have rotated your keys recently. And you see that those like 5 green checkboxes. Only if you see them, you're probably good to go. Yeah. And the password policy is also pretty powerful, where you can define, okay, passwords need to be at least that long and need to contain some special characters and numbers and everything. So they make sure you don't screw up. And finally, 1,100 points. If you have premium support, that's at least our experience, premium support is the best investment. So it costs at least, depending on which level you want to take, but for us it costs 10% on top of the existing bill you pay for premium support, but that's really a lifesaver, because otherwise you just have a public forum where you can post your problems. And with premium support, you actually get some human who will respond, really respond to your problem within a reasonable amount of time and help you out. And on top of the human who will help you out, both if you have been compromised or I don't know, if your instance got stuck or something like that, they have the so-called trusted advisors, including one for security. So they have kind of a dashboard overview where you see how you're standing. So both, can you optimize the cost? How is the performance of your infrastructure doing? Do you have any security issues? And how is fault tolerance coming along? So you see what's good, what's bad, what probably needs work. And for each point, you can see the details. So I think for security, the two major problems we have there is that we are not using CloudTrail in regions we don't use. We don't really care about that. And the other thing is that we allow, or that we have firewall rules that allow global access, for example, for port 80. I'm not really sure why that's a major warning, because allowing global access for HTTP or HTTPS is kind of a normal thing, but yeah, well, maybe we need to add an exception there. But otherwise, it's a nice way to get an overview, how is my infrastructure doing. Okay, so now we know what we should do in general. How do we actually implement that in our code? The first thing is, if an API key or an account has been compromised, always rotate the keys and passwords. Don't think you're clever, because someone else is more clever. There's this nice example of some guy posting 100 servers running on my AWS account. What? How? I only had a 3 key on my GitHub and they were gone within 5 minutes. So this guy had the case where he was only using S3 for file storage and no other services, but I guess he just used the root account, even though he was just accessing S3, so first major problem. And the second major problem is he committed his credentials to his GitHub repository and pushed it, and right after pushing he noticed, ooh, I shouldn't have done that. And then he did a rebase and cleaned the history, and the keys were gone from the history within 5 minutes, and he thought, okay, within those 5 minutes, my little project, nobody will have noticed, nobody will have seen it, all is good. Unfortunately, the bad guys are monitoring pushes to GitHub and scanning them for keys. So even if you've just pushed and revert immediately afterwards, your keys are probably compromised, even if it has been just up for like a minute or so. So if your key has been probably compromised, reset it, it will save you from a lot of trouble. The next thing is, where do you actually store your keys then? So if you should commit your keys to your GitHub repository or Git subversion, whatever you're using, where should you keep them? I think there are two general approaches. Either keep them in environment variables or encrypt them in your source control management. So the first approach is, don't store any credentials in your code, but just create environment variables on the instance from where you can read them. The problem is, if you have many attributes and you need to keep them in sync across all your production servers, development servers, and local environments, it can be quite a hassle to keep all those environment variables in sync. So that's the reason why we don't really like it that much. And we're leaning towards the encrypted files in source control management. And there's a very nice blog post, Keeping Passwords in Source Control by John. Does anyone know who John is? Yeah, okay. He wrote some little jQuery thing, nobody knows about it. So he's kind of famous, and what he basically has is, so he also said, keeping all the passwords, and so we have so many passwords in the environment variable, and keeping that in sync on my local development machine, the development machines, and the production machines is too much hassle. So they want to keep that in source control. So for the local credentials, they don't really care. They just keep that in plain text because, I don't know, your MySQL database probably has the user root and an empty password that's only available on the local host, but nobody will really care about that, so no problem there. But for the development and production settings, there's just, for example, you can use a simple shell script. That's something like we're using, and we simply call shell script on a file, and if it doesn't have the extension AS256, it will encrypt the file, and if it has that extension, it will decrypt that file. So how does it look in reality? So for example, we have a trust store containing our wildcard SSL certificates, but it's the same if you have a property file with your API keys or database passwords or whatever. You have the encrypted file, you run the encrypt properties shell script, then you enter the password, or if you don't have it, we keep that message on the top. So if you should have the password but you don't have it, at that email address you can get it, or from the colleague who is sitting next to you probably. And after running the script, you will have your decrypted trust store besides your previously encrypted trust store. And we have a git ignore rule for the trust store JKS, for example, so that we can never actually commit and push that to GitHub. So we always make sure that we keep the sensitive information like properties or SSL files out of our, or in an unencrypted way, out of our Git version control. Or probably you want to use a more fancy version. So if you're using Ansible, I think there's a talk about Ansible today, and it's awesome. We're using it as well. There's the concept of an Ansible vault, which will basically wrap that for you, which will also have its own vault where you provide your password, and it will then know, okay, if you run some playbook, they call it, so if you want to run some action and you require some encrypted property, it will ask for a password, get the password from that vault, and only then use it. And you can push your vault to GitHub. It's heavily encrypted, nobody can decrypt it without your password, so choose a really long password because you're only pasting it into the shell anyway. So that way you are secure. Or HashiCorp has released, so HashiCorp are the guys behind Gradient and many other products. They've just 1 or 2 weeks ago released something similar. They also call it Vault, and that's basically a network-based access for that. So you can provide your credentials over the network, and then only then you will get your access key. But they will time limit it, and they will allow you to audit it and revoke keys and stuff like that. So that's really handy if you have lots of keys to manage. Okay, so how do we actually deploy them? It looks like this. We keep everything, all our secrets in an encrypted file. Once we push the code to GitHub, our build server, like in the keynote, we're also using Jenkins, will build or test your code. And then we store the final build we then want to deploy on Amazon S3, so the file storage. You can probably skip that step depending on your requirements. Then we push the code to EC2, and only if it's on the instance, we only decrypt the file that's required. So you always have properties for the development environment and the production environment, and on the development environment, we will only decrypt the development passwords, and on the production system, only the production passwords, obviously. And that way, we don't need to synchronize any environment variables, but we have a single file containing all the secrets, but that's in a secure fashion, and only the people having the password can actually do anything with it. So even if you have developers, new developers, interns who you don't really trust, as long as you don't give them the credentials, they can check out your code and add code, but they cannot see your credentials from the production environment. So an additional bonus there. Okay, and finally, trust. There are some services we need to trust. So for example, we need to trust GitHub, we need to trust our build server, and we need to trust Amazon basically, so they get our code. They only get the encrypted files, so we only push the encrypted files to GitHub. The build server only sees the encrypted files because the test settings for the CI server are also not encrypted because they're not that valuable. And Amazon in general only sees the encrypted values as well. But they need to get our code. What we are very skeptical about is giving GitHub access to external services. So there are very, very nice services, like my colleagues always want like a Kanban board for GitHub issues where they can drag along tickets and they mark the state like in progress or fixed or whatever. But we don't really do that because there are many small companies doing that, but we don't really trust them. Because if you're just like 3 or 4 people, you don't have anyone working full-time on security, and you're probably not putting in the effort we would really need to trust you. So yeah, stuff like WhoBot, which does this Kanban board, for example, or Waffle.io or whatever. Really nice products, probably good for open source, probably good for side projects, but we don't really want to give them access to our source code. even if the credentials are encrypted, we don't really trust them that much. Yeah, and that's basically it. Any questions?
Thank you for the talk. You didn't mention STS, the services from Amazon able to deliver token limited in time in access to resources. You didn't use it, or is it not secure enough for you?
We didn't use it because, well, maybe we've been too lazy or we've been too busy with other stuff. So you mean you can, on Amazon, you can have all of these time-based access credentials. So we're using that for part of it. So for example, we have services which need to download stuff from S3, and there we just generate something that's valid for 10 minutes. To fetch the credentials, we put that on the instance so it can fetch the artifact we want to deploy. That's a time-based key, yes. For brevity, we're using that, but we are not using it too widely for other stuff. It's something we might want to look into the future, but we don't really care for it too much, because with all the other steps we're already taking, we don't feel that that's really necessary, and it's kind of an overhead, because you have all these, you need to set up the infrastructure to generate the keys, and then if you reuse the service after some time, you always need to get the new key. But it's definitely a valid solution, but currently we mostly rely on IP restrictions and separations of concern and stuff like that. Any more questions, or everybody up for lunch? Lunch. Lunch one, obviously. Yeah. If you want to leave a review, thanks a lot already.